Hey everybody, Mr. D here checking in for Math Muscle, more on vectors. In this case here we have an application type question where we're given a three-dimensional figure and we're asked to find using vector methods the measure of these two angles. The vertex of each angle is angle n, but the actual angle themselves are slightly different. And we're given that the side lengths of KL, LM, and LX, like those lengths there. In other words, the three dimensions of this particular rectangular prism are 8, 5, and 3 respectively. So we've got our work cut out for us. And we also know that P is the midpoint of side length KL. So how do we go about and start this question? Well, one of the methods that you can use is to place the rectangular prism on a coordinate axis in order to generate points, in other words, coordinate points, and ultimately component vectors. So I'm going to go about and just basically copy this, and on one of the, in this case here, I'm choosing to use this particular vertex, KLM and XLM, XLK, as the actual axes, the X, Y, and Z axes, as you can see here. And then I went about and labeled the corresponding components. So in other words, the x-axis, this would be negative 8, 0, 0, because we know LK, or KL magnitude, is 8 units. We also know that LM, we're given in the question, is 5 units, which means that on the z-axis that I've drawn here, our z component is 5, and the other two components will be 0, which is consistent with any point on any axis, whether it's 2-dimension or 3-dimension, that the other components or coordinates will be 0. And you may have guessed that on the y-axis, the value that we know for the length of Lx, which is in fact 3, that's going to be our y component or of that particular vector, and the x and z are going to be 0. So if we're interested in finding point n, because that's the vertex of each of the angles we're looking for, then we know that we're going to have to go along the x-axis, negative 8, along the y-axis, 0, there's no real height there, but along the z-axis, we're going to have to go 5. That's how we came about with point n, negative 8, 0, 5. And point y, which is also going to be known, that's going to be required for that angle, is going to be on the x-axis, we aren't going left or right, but on the y-axis, we're in fact going up 3, and on the z, we're going 5 units. Hence, those two particular coordinate points. Now, keep in mind we want to find an angle, and usually when we're finding the angle and using vector methods, that involves the scalar product from our formula booklet. So we need the vectors that actually create that angle, y, n, x. So I'm going to go ahead and try to draw to give you a better idea of y, n, x. In other words, we're going to go from n to y. There's one vector. And then we're going to go from n to x. And you can see how that vector combination, the angle between them, will be the unknown value. So that's actually what we're going to be looking for right there, is this angle y and x. So we're given two vectors that create that particular angle, and we stated in prior videos, if you had a chance to view them, when we introduced the scalar product, and I suggest you go back to that video if you need a refresher, you'll notice one of the prime motivators for the scalar product is to find the angle between two given vectors. So we need the actual components now of ny, vector, and an x vector, the red and the blue vector. And you go about doing that using negative of the original position vector plus the position vector that ends at the second value, and the same thing for ny, negative on plus oy. Those are vector basics for position vectors. And then you just go ahead and substitute and simplify in component form these particular values, and you come up with nx and ny vector respectively. Now that we have that, we can go ahead and use your formula booklet and substitute in for v and w. We're going to sub in nx vector and y vector respectively. Do the Cartesian component method, or the Cartesian value of the scalar product. So that's 8 times 8, multiplying the x components, add the product of the y components, add the product of the z components, dividing by the magnitude of each of those corresponding vectors. Once you have that, you can use cos inverse, make sure you're in degree mode, and you'll find that the angle between the two vectors is 30.3 degrees. So in that case, if we go back up to our drawing, the vector that we were looking for, the angle between those two vectors we were looking for is 30.3 degrees. Similarly, to do y and p, we would have to use two vectors to find angle n framed by ny. So we already have ny in red. And then np would be this one here in green. So now we're looking for actually the angle between ny and np. And you can go ahead and try that. Basically what we need are the coordinates of this point P, and I'll get you started off on that, and then you can try to do the rest on your own. Because this is on the x-axis and from L to K is 8 units long, P is the midpoint of KL. And in case you haven't thought about it already or figured it out, you'll see that it's -4, 0, 0. That'll be the point P. And then from there, we can come up with NP, NY, and then use the same process that we did already. I hope that helps. Check that out, try it out, and stay tuned to more content from Math Muscle.